friends, welcome to the channel of Digital to Real. Today we are going to discuss about blocking and non-blocking assignments in Verilog. आज हम किसके बारे में डिस्कस करने वाले हैं? आज हम Verilog के ब्लॉकिंग और नॉन ब्लॉकिंग असाइनमेंट के बारे में डिस्कस करने वाले हैं. Verilog supports two types of assignment within the always block. ऑलवेज ब्लॉक के अंदर वेरिलॉग सपोर्ट करता है दो तरह का असाइनमेंट. पहले हम देखेंगे ब्लॉकिंग असाइनमेंट. ब्लॉकिंग असाइनमेंट द इवैल्यूएशन एंड असाइनमेंट हैपेंस इमीडिएटली. ब्लॉकिंग असाइनमेंट में क्या होता है कि असाइनमेंट स्टेटमेंट का जो राइट हैंड साइड होता है उसका इवैल्यूएशन और उसका असाइनमेंट टू द लेफ्ट हैंड साइड इमीडिएटली हैपन होता है और वो होने के बाद हम नेक्स्ट स्टेटमेंट में प्रोसीड करते हैं. Just see the always block. Always at the rate of A or B or C. Begin end. Okay. Here begin and statements are there. Inside the begin end, first statement is we are evaluating A or B and assigning it to X. Here we have used the blocking assignment. Okay. So evaluation of A or B will happen and immediately it will get assigned to X. And then only it will proceed to the statement of y equal to b and not of c. Here also b and not of c would get evaluated first and then assigned to y immediately. Okay. And then it would go out of the loop of always block. Okay. So in always block, having the blocking assignment, once we proceed one statement and it finishes the evaluation and execution assignment, then only we proceed to the next statement, then it get evaluated and then assigned and then we come out of the loop. Now non-blocking assignment. So in non-blocking assignment, all assignments are postponed. They are postponed until all the right hand sides have been evaluated. So you see the always block. Same example which I have shown for blocking. The same example I have put here for non-blocking. You see always at the rate of A or B or C. Okay. Begin X. Here is the non-blocking symbol A or B. So we are evaluating the A or B, but we are deferring the assignment of X. That means we are evaluating it, but we are not stopping for the assignment to X. Rather, we are evaluating it and moving to the next statement of Y non-blocking assignment B and not of C. Here, you see, here also we are evaluating the B and not of C, but we are deferring the assignment of Y. So, we are deferring. Means we are postponing the assignment to X and Y. When the X and Y will get assigned, once we will finish all the evaluation, and after that at the end of the time step the assignment will happen. Means we come out of the begin and end statement, this block, and now they assign the values of X and Y. So now the new values of X and Y will be assigned. So inside the begin and end it won't happen, only the evaluation part will happen. The moment we come out of it, the X and Y value will get assigned. Similarly, always at the rate of A or B or C means this is a sensitivity list. Whenever any of the three variable changes, we will enter this loop. And every time the assignment to X and Y will not happen immediately. Rather, it would end the moment we come out of the begin end statement. Okay. We come out of the block. And here in our case, at the end of the time step. Okay. Now, non-blocking assignment is used for sequential logic. In order to design the sequential logic in the RTL, we use the non-blocking assignment. Okay. And for combinational logic, we use the blocking assignment. Okay. Combinational logic is implemented with blocking assignment. So, we will see another example. Now, let us see how non-blocking assignment is used in sequential logic and how blocking cannot be used. We will see why in non-blocking statement only used in sequential logic but not the blocking, And in combinational logic, why we use the blocking statement only, not the non-blocking. Okay, here is a flip-flop based digital delay line. You see, so these are the 3 D flip-flop. Here is the in input. Clock is applied to all the 3 D flip-flop at a time. Okay. So here is the module which is showing the non-blocking module, which is showing the delay line. Okay, digital delay line code of 3 flip-flop. So here is the input ports in, clock and out. In and clock are the input in nature, output. Out is output in nature. Reg, Q1, Q2, out. So these 3 are of registered type. Okay, Q1 and Q2 are 2 internal signals of registered type. Out is of registered type. Always at the passage of the clock. Okay, we are going inside the begin end block. So Q1 non-blocking assignment in, Q2 non-blocking assignment Q1, out non-blocking assignment Q2, and here is the end module. Okay, here I have written for non-blocking case, non-blocking case. Now we will see the blocking case, how the blocking module is written. Same module blocking, in, clock, out, input in and clock, output is out. Reg Q1, Q2, out. Okay, always at the begin, at the passage of the clock, begin. Q1 blocking assignment in, semicolon, Q2 blocking assignment Q1, semicolon, out blocking assignment Q2, semicolon, end and end module. Now, at each rising edge of Q1 of clock, Q1, Q2 and I out simultaneously receive the old values of in, Q1 and Q2. That is how we have seen in the non-blocking assignment. Non-blocking assignment code we saw, no? At every passage of the clock, we will enter this block. Okay, at every passage of the clock, we will enter this block. So, in will be evaluated, Q1 will be evaluated, Q2 will be evaluated, but they won't get assigned to Q1, Q2 out. Assignment will happen once we come out of the begin end block. Okay, so they will get Q1, Q2 out will get the old values of in, Q1, Q2. Means because we are not stopping for the assignment to the Q1, we are just evaluating the in. So we will not wait for the statement to get finished and then move to the next statement. Rather, evaluation will happen, we will move to the next statement. Evaluation will happen, we will move to the next statement. Assignment to Q1, Q2 out will happen once we end out of this block. Begin and block, always block. Okay, at the next passage of the clock, Q1, Q2 out will get the value of in, Q1, Q2, that also the old values. So that is what has been said. At each rising edge of the clock, Q1, Q2 and I simultaneously receive the old values of in, Q1 and Q2. That is called non-blocking assignment. Now, what happens in the case of blocking assignment? At each rising clock edge, Q1 is equal to in. So, we will evaluate the in, assign the Q1. After that only we will move. After that only we will move to the next statement, that is Q2 equal to Q1 equal to in. So, we will move to the next statement. Okay. So, here Q1 will get the value of this in. Q1 is equal to in. Okay. Q2 is equal to Q1 and out is equal to Q2. These are all blocking assignment. Once the Q1 is assigned the in value, then the new value of Q1 will come here and it would get assigned to Q2. The new value of Q2 will come here and it would get assigned to out. So this is how blocking assignment works. So At each rising clock edge, Q1 is in. After that Q2 is Q1 equal to in. New value of Q1, Q2 will get. And after that out is equal to Q2 is equal to Q1 equal to in. So out will get the new value of Q2. So finally out is equal to in. This is called the blocking assignment. Okay. So blocking assignment do not reflect the intrinsic behavior of multi-state sequential logic. Means with blocking assignment we cannot reflect the internal behavior of a sequential logic. How we expect a multi-state sequential logic to work, we cannot implement with the blocking assignment. So now, because for the flip-flop based digital delay line, we saw, no, for every clock Q1 is updated, Q2 is updated, out is updated. Immediately in value doesn't go to the out. It would get about 3 clocks, passage of the clock, for in to get transferred to out. That is why we will get the delay of 3 clocks. Okay, that is the digital delay line. This functionality cannot be implemented with the blocking assignments. So now we will see how blocking assignment is used for combinational logic. We saw the functionality how non-blocking assignment is used for sequential logic. Now we will see how the blocking assignment is used for combinational logic. Always at passage of the A or B or C, begin end, X is equal to A and B, Y is equal to X or C. Here X is what? Updated value of this X. Okay. So first of all A and B is evaluated and assigned to X. Then X and C are odd and then assigned to Y. So this is what is the functionality of the combinational logic. Now suppose we have this blocking assignment, okay, where there is no postponement of the assignment. Here we have the evaluation and assignment at the same time. So initial condition is that always at the rate of A or B or C. Suppose either A, B or C changes, then only we will go inside the always block. First instruction is X is equal to A and B, and second is Y is equal to X or C. So initial state, suppose we have A, B, C, the values I have A, 1, 1, 0. 1, 1, 0, if it is that, initial value X is 1 and Y is 1. This is the initial state. Now A changes the value from 1 to 0. We come inside the always block. Okay. After we come inside the always block, so 0 and 1. So X is 0. First of all, the change is happening. Then X is assigned the value of A and B. 0, 1, 0, 0. X is assigned 0 value. We didn't move to the Y is equal to X or C. This is executed. Okay, 0 is executed, Y is 1. Then we move to the 0, 1, 0, 0 and Y also become 0 or C is 0 is equal to 0. So, this is how the blocking assignment works. Okay. Now, for non-blocking assignment, initial condition, I have the same initial condition. A changes, then only after the A changes, the always block is triggered. Okay. X, non-blocking assignment, A and B. Y, non-blocking assignment, X or C. Now here you see 1, 1, 0, 1, 1. Same initial value of all the 5 variables. A changes value. We comes inside the always block. Always block is triggered. Okay. So after the always block is triggered, what is the value? X is equal to A and B. A and B is evaluated but are not assigned. So X is evaluated, the value 0 is evaluated for A and B, but it has not been assigned to X. So X will get the value 1 only. Okay, we won't stop here. Okay, and we will move to the next statement, that is Y non-blocking assignment X or C. Here also old value of X, that is 1, old value of X is used in order to evaluate the value of Y. So 1, 1 or C or 0. So 1 only. Okay. But here also assignment doesn't happen to the Y. We come out. We come here. We come out of the always block and then only the assignment happens. X is assigned to the value of 0. Y is assigned to the value of 1. Inside the begin end statement, assignment does not happen. Only the evaluation of right hand side is happening. X and Y are not assigned. Okay, you see here X and Y are same. X and Y both are 1, 1 only. There is no change in value. Once we come out of the loop, X get the value of Z, Y 0 and Y get the value of 1 after the always block. So non-blocking assignment do not reflect the intrinsic behavior of multi-stage combinational logic. So for multi-state combinational logic, where we want the immediate effect of input to output, that cannot be implemented with the non-blocking assignment. Hope you liked the video and hope you found the information informative. If you like the video, please subscribe the channel and please share the video with your friends. Thank you. Have a nice day.